Here's what I gave you November 4th on Wednesday to complete by yourselves. I gave you 2 points if you wrote down the method that you needed to use to find the derivative. And in this problem, you needed to use the chain rule. And I also gave you half credit. The points here were in addition, kind of like extra credit. In addition to that, I gave you half credit for writing the denotation and half credit for completing the problem. So, for instance, I gave you half credit if you did put this in this notation right here. I also gave you credit if you didn't do this and you took the derivative and got it correct. However, if you got the derivative wrong but you got this correct, I still gave you half credit. Otherwise, it was either completely wrong or completely right. Just finishing it off, you get this answer, and I'll actually go through it actually. You're taking the derivative of sine of 3x, leaving 3x by itself, alone, leaving without affecting the 3x, meaning 3x is what remains constant. So the derivative we're taking is just of sine itself, which is cosine, and we're going to leave the 3x alone. And then we're going to multiply it times the derivative of the inside, which is the 3x. That's what this represents. The derivative of 3x, leaving the x alone, and that's just 3. Okay. And just cleaning it up, you end up with 3 cosine 3x. For this problem, we have a product of 2 functions, and so that makes that gives us the opportunity to use the product rule. And here we go, giving you half credit just for writing the notation. We're going to do the first times the derivative of the second with respect to the inside. And in this case, the inside is x by itself. Then subtract, add the derivative of x with respect to x times the second function. Finishing it off, we have x. The derivative of sine is cosine x plus the derivative of this is just 1 times sine, and just write it again without the 1, and that completes the simplification. And we're done. Here we have one where we need the quotient rule. Okay. And writing it out, you have the bottom times the derivative of the top. Whoops. Excuse me. That's more like it. Minus the derivative of the bottom times the top. All divided by the bottom squared. Okay. We have x. The derivative of sine is cosine minus right here. Derivative is just 1 times sine x, and all over x squared. And that's it right there. All you have to do is just rewrite it without the 1, but you already know the 1 doesn't need to be there. These x's cannot cancel. You can't cancel those x's. If there was an x here, then you can factor out an x, and then you'll end up with an x here. And then you can cancel. Otherwise, you can't cancel, and you're just left what we had before you tried to cancel. I've seen this a couple times in this test already, which is why I brought it up. Here we have the chain rule. All you have to do is rename it so that you got rid of the radical. Just get rid of the radical, and here we're using just the chain rule. Okay, so writing it out, I want to make sure you start out with the whole function written out, because that's what we're taking the derivative of. With respect to just the inside, and in this case, we have the outside function, and this is the inside function right here. Okay. And we got to keep multiplying it until we've gotten rid of all the inside functions. So we'll take the derivative of the inside function with respect to, whoop, got our little x there. With respect to, in this case, the inside function is the x. Now be careful. It's sine of x, not sine of x plus 2. It's not this right here. Okay? It's this right here. If it was going to be x plus 2, it would be very specific by placing the parentheses there. But since the parentheses are not there to indicate that we're taking the sine of x plus 2, we can assume, this is implying, not that we can assume, this is implying that it's only sine of x by itself. And then after you take the sine of x, it's plus 2. Okay? And so this is with respect to x, not x plus 2. And now that we have with respect to x, we're done. And now we're just taking the derivative of this, bringing the 1/2 to the front. We're leaving this part alone. And multiplying it times the derivative of this part, which is a derivative sine is cosine x. And the derivative of 2 is 0. So I don't need to write that. Okay. And it's all done. However, I did miss this to negative 1/2. Okay, because we got to subtract 1 from this. Okay, so it's to the negative 1/2. So we're not done actually. So what goes on the bottom here is this is on the bottom, and this is already on the bottom too. So when we rewrite it, we can write cosine on top, not affected by a negative exponent, and 2 sine x plus 2 raised to the 1/2, so it's a square root. Now we're done. And here we have a trig function with the square root inside the trig function. So we took, of course, like we always do, we take the square root, change it to 1/2 instead, and take the derivative of the whole thing, tangent, 1/2. And all we do is we take the derivative of the outside, okay, and take it with respect to anything on the inside. Actually, that's not correct. Wait a minute. Yes, it is. Okay, so keep in mind, this is, oh, excuse me. Fix that right there. This right here is the inside portion right here, okay? And so we take the derivative of the outside first, which is just this part with respect to the inside. Then we multiply it times the derivative of the inside. And this whole thing is the inside. Okay. Now we have another inside right here, so we have to take it with respect to that inside. And we keep going until there's no more inside functions. So we have derivative of 3x. Now we have a linear function, and the linear functions respect to x. There's nothing inside, just an x, except for the x. And just one more time, I've done this in class. If you notice how those cancel, and when it's all said and done, we are actually taking the derivative of the whole function with respect to x, and that's how the math works out in D notation. So finishing it off, taking the derivative of tangent just by itself, leaving this alone, derivative of tangent is secant squared of whatever is inside. And multiply it times the derivative of this, well, the derivative of this function, just paying attention to the outside part, bringing it over, leaving the inside part alone. to the 1/2 minus 1, which is negative 1/2, times the derivative of this linear function, which is just 3. And so just cleaning it up a little, we're going to make sure we have what's on the bottom, this part, and everything being affected by the negative 1/2. And when you're done, you can also, we're going to bring this one over to the front as well, giving it, and here you go. And there's the square root, cleaning it all up. And here we have a example for quotient rule and the chain rule. Quotient rule because of the division, and the chain rule because of the square. And it can be written this way too, just so you can see that there's an inside function more clearly, like that. Okay, so using the quotient rule, denotation to give you some points, you end up with the bottom times the derivative of the top times the derivative of the top with respect to x minus the derivative of the bottom with respect to anything, any inside function, and there's an inside function which is this one right there. So we leave that alone, and we got to keep taking derivative until it's with respect to x, which we can in this case. Okay. So that's the derivative of the bottom. All this derivative of the bottom times the top. Okay, so there's the bottom, and for the left side, so taking the derivatives, you get this, and what we want to do now is just clean it up. We want to combine these two. We want to bring this negative out here, making that positive, and we want to distribute that cosine, making it cosine cubed plus cosine over there, and I'll write it out. But first I'll shrink it, and here's what it looks like after everything's done that I just explained. Just like that. And what hopefully you can recognize, if not, keep in mind that if you can factor something, if there's something in common in all the terms in this class, you should factor it out to see what kind of simplification it could lead to. There's a cosine there, there, and there. Those three cosines can be factored out, leaving you with a 1 here, 1 here, 2 cosines here, and the cosine here turns into a 1, so you just have 2 sine squared of x. And writing it out, it looks like this. Okay, and this right here needs to be said. You see a sine squared here and a cosine squared, and they're being added. An identity should immediately pop out to you, which is this one right here. And how can this identity come out of this is that when you add 2 of anything, you can separate it by this being sine squared plus sine squared, like this. Just keeping in mind that this right here equals 2 sine squared x, just like x plus x equals 2x. And right here, this right here equals 1. So you add this one to this one, plus sine squared x, and we're finally done getting us our final answer here. Okay, the last question was easier than the previous ones. And the only issue I can foresee is that maybe people might think that this is multiplication, but this is just like saying sine of x. It's just sine not of x, but of cosine of x. And here you just use the chain rule. Okay, our denotation gives us this being the inside function, okay, and our final answer being that right there.